In this video, we are going to look at graphs of power functions. You will find this on page 254 in the Namibian Ordinary Level Mathematics textbook, y equals mx plus c to success. Graphs of power functions, y equals ax to the power of n. Okay. The function a, y equals a x to the power of n, where a is a rational constant and n is a rational number, is called a power function. In section D, we shall study the graph of this function for when n is -2, -1, 0, 1, 2, 3. So it's not just a 2 there, it can be -2, -1. We actually did already -1, but it can also be a 3. Okay, so a little bit of a variation. So the general form of the equation of a power function is given by this, where a is the rational numbers. But now, let's look at the graphs. If n is 0, anything to the power of 0 is 1. Let me just get that. So then it will just be y equals, say, 4. So the x will disappear and it will just be a straight line and it will cut only the y-axis. Okay. When n is 1, okay, put a 1 there. Then it's going to be a straight line, and because there's not a value of c, or the value of c is 0, it goes through the origin. When n was 2, it was the hyperbola. But now, if n is 3, it's going to be the cubic function. Okay, this is new. We already did n is -1. This was the parabola, and this was the hyperbola. Okay, I hope I said it correctly previously. Parabola, hyperbola. And then this one, when n is -2, not -1, -2, it becomes a graph. I don't want to say it looks like this, but it's not in say 1 and 3 or 2 and 4. It's actually like in 1 and 2 in this quadrant. And the shape also differ a little bit. Okay, but we will look at that. So graphs of sums of power functions, combinations. When two power functions are added together, they form a new function. For example, say this, and y equals x. Okay, so it's 2, and if I combine it, it's going to look like this. The shape of the graph of the new function may be quite different from those of the individual functions. We can use the construct a table method to draw the new function. The best is just to make a table, complete, do substitution, complete the table, plot the points, and you will see how the graph looks. So it's not especially if I start to add and find different ones, different power functions added up together, the shapes can change. So let's look at this one. So in this case, so you will say it's 4x plus x. So if I look in this case and I give you the table, now very important, why can x not be 0? Because dividing by 0 is invalid and I must block it out. And that block out means that I cannot put a line like this or a line like this. I cannot go over the y-axis. Very, very important. If you connect that two, you are going to lose marks in the exams. Okay, so in this case, calculate the value of p. Again, just do substitution. Do it nicely in brackets and you get your answer and you complete that. And then using your graph, 1 centimeter, 1 above, that's what I did, and I just start plotting my points. And it's a curve, it's curves, so just draw the one, stop, draw the other one, stop. And then use your graph, we did this already. So if we are going to say, in this case, let's make it red. So it's actually in the place of y is equal to 0. And can you remember? Although this is called, the name is the x-axis. But the equation is y equals 0. Okay, so the name is the y-axis, but the equation is x equals 0. Okay, so basically then I'm just going to do it like this. Where does it cut? And it's only one that cuts. Do you see? So it's only x is equal to -1.6. And then this one is equal to 4, then I'm just, again, in the place of y, it's now 4. So you draw that line. It cuts the y-axis, and it cuts at 4. And now it cuts 3 times. 1, 2, 3. So draw down, read down, negative 0.9. Read down, 1.1. Read 3.8. And that's your final answer. Okay. Again, I want you to take graph paper. I want you to stop the video, and I want you to do number 1. You can continue the video as soon as you are finished. Take your time, do it nice, sharpen your pencil, because it's also going to help you with accuracy, and then you just do that one. Okay. Okay, let's start with this one. I like to start here before going to the graph paper, just to see if there's one that I have to work out, a missing spot. And there's actually quite a lot. That's the same, okay, B, B, and A. I'll see now why there's the same value. I'll show you now. Okay, so let's start. Number A. First step, write down your equation. And then it's negative 3. So in the place of x, I put negative 3. And if I simplify this, and 1 minus 1 over 9 will be what? It will just be 8 over 9, okay? And they said find the values correct to 2 decimal places. So if I simplify that, so it's going to be 8 over 9, but they wanted a decimal. So if I make it 2 decimal places, 0.89, but don't forget, therefore, A is equal to 0.89. Okay. And if I do the next one, I just want to check quickly something. Okay, the next one, it's number B. So again, start with that. So it's y equals 1 minus 1 over x squared. 1 minus, and what is x squared? In this case, it is negative 0.3. So it's 1 minus, and don't forget to square it. And you can press it on the calculator, but if you say, for example, negative 0.3, close the bracket, square, so it's going to be 1 over 0.09. And if I press that on the calculator, I'm going to get negative 10.11. Make it a decimal, otherwise you cannot plot it like that. So again, therefore, B is equal to negative 10.11. Don't forget, I want to show you, and I'm just going to show it here. If you substitute that positive 0.3, why is it the same answer? Because it's 1 minus 1 positive 0.3 square. And it's 1 minus, and that it's also 0, because a negative times a negative is a positive, and this one stays positive. So it will give you exactly the same value. That's why they use the same alphabet letters. They must use it if the values are exactly the same. And the same here. Can you see? If you're going to do this one and you substitute 3, and I want to show you, and I'm going to show you by making use of this. Put 3, then you're also going to get 9, and then you're going to get, and that's why they just repeat it there. So it's just finding A and B. You don't have to do it there again. Okay, so on a sheet of graph paper, using scale 2 cm to represent 1 on the X and 1 to represent 1 on the Y, and draw the graphs. They actually tell you from negative 3 to, from this to this, and they tell you from this to this. They cannot just make it so, because they don't want you to go over 0. That's why they block it out there. Okay, but let's go to the graph paper. And again, the first step is just copy that table. And it's such a long table, and I'm going to see if I can copy it. I don't know if I copy it on top, because it's so long. I think I'm going to just make it smaller. Then I don't have to need so much space. Okay, so this is going to be x, and this is y. And as I said, it's quite a long table, so it's -3, 0.89, -2, 0.75. You don't have to copy it, you already have it. I'm just, because I work on different pages. Okay, so -1, and it was 0. -0.5, and it's -3. -0.4, and it's -5.25. -0.3, -10.11. And I prefer always, if this happens, now let's take another color. So it's just that you remember, don't go over the y-axis. So again, this is going to be 0.3, and this is -10.11. This is 0.4 and -5.25. And this is 0.5 and -3. And this is 1 and 0. And I can even draw a line there. And this is 2 and 0.75. And this is 3 and 0.89. And then I just draw the lines. Okay. Okay, and now I'm just going to plan my axis. So in this case, okay, that is fine, but just look at the y values. So the lowest one, it seems to me, is that -11. Do you see -11? The highest one, what is the highest one? It was just, not more than 1. Okay, and so this one can be in the middle. This one can be in the middle, but then the graph must be just a little bit positive and a lot negative. Okay, so let's just do that. So we said that this will be fine. Let's make it blue also, if it's in the middle. So I think here it will work. Okay, and then we said that we are going to do this is 2 down. I'm going to just make it bigger that I see that line better. 2 down. And this is going to be my x-axis, and this is my y-axis. And then the units, so they said, and I just repeat it for you, 2 centimeters to represent 1 unit on the x-axis. So every 2 centimeters, it's going to be 1. And then they said 1 centimeter to represent 1. So this is 1, 2, -1, -2, -3, -4, -5, -6, -7, -8, -9, -10, -11. Okay. And now I think we are ready to start plotting. So, if we start plotting, it's a bit challenging with all the decimals, but let's just try to do it to the best of our ability. So in this case, it's -3 and it's 0.89. Now remember, it's 1 divided by 5, so it's 0.2, 0.4, 0.6, 0.8. So 0.89. So it's almost going to touch there. Do you see? So but it's not touching. I want to take another color. 0.89. And then it's -2 and 0.75. So 2, 4, 6, 7. Okay, so 8 will be there, but it's a little bit lower than. Okay, so 8 is there. Let's just go again. 2, 4, 6. There is 8. Okay. 7, 5, so it's a bit higher than the middle. Okay. And then the next one, -1, oh, this is nice, and 0. Then -0.5 and -3. And -0.4, there is 4, because this is counting 0.1, 0.2, so there is -0.4. And it's -5.25, so -0.4 and 5.25. Now it's a bit higher. Okay, so -5.2, and it's a little bit lower. Okay. And then this is 0.3. Okay, so it's 1, 2, 3, and it must still go down. Okay, remember, so it's -0.3 and I'm just going to -0.3. So this is 1, 2, 3, and it's -10. Okay, what was it? -10.11. So there's -10.2, so 1, it's approximately here. Okay. And then the next one is it's 0.3, so it's again 1, 2, 3, and now it's going to be the same. Okay. And then the next one is 0.4, and I think it's the same there as that one, so but it's just 0.4, and it's -5.25. Okay? And then it's going to be, I can actually move like this that I can see. Okay, so 0.4, 0.5, oh, it's so nice. 0.5 will be that -3. 1 will be that 0, it's symmetrical, can you see that? And 2 is 0.75, but higher, and then 3 is 0.89. And now to draw these graphs, remember you cannot connect this to, there's nothing going on there. Okay, so if I start and I must draw it, okay. Oh, I think I'm going to redo it. Let's start again. The thing is just, I think it can be rounded there. The more accurate you draw this line, the more accurate will your answers be, reading from the graph. So it is very, but you can move your paper, I cannot do that. I wish I could have just reflected. What I sometimes see, as I said, if you at a point, it will not show that you were picking your hand up there. Okay, so that point was actually nice for me. Okay. And again, I think we were actually fine until there. And then I don't think it's so nice. Okay. Okay, and that's how it's going to be. The best of my ability, but try to do it more perfect when you do it on graph paper. Okay, with this technology. Okay, now we start with the questions. Now, they say write down an integer k such that y equals k has no solution. Now where will it have no solution? Now, if you look at this, okay, let's just see. If I draw the line there, it's not cutting. If I draw it there, it's cut, and actually there also. So if I'm going to see, so did they ask me for a range or just a specific value? Rather than an integer k that has no solution. But it can also be, so can you see if I draw the line at 1, y equals 1, it's not cutting. But at 2, it will also not be cutting. At 3, it will not be cutting. At 4, an integer, not a fraction. So I'm just going to give you one example, and that's number C, and then k is 1. But remember, it can also, k can also be equal to 2 or 3 or 4, okay, anything. And even at the bottom, negative 11. Now, if you look at number D, let's just come to question D. On the same grid, it's again a straight line. Now, usually, they don't give you a table. And if they don't give you a table, still the best way to draw it. You can do it with, cut the x-axis, cut y-axis also. But I think sometimes it's just nicer to just quickly draw your table. And look at their range. They tell you that the x values must be from negative 3 to 3. So that means negative 3, 0, 3. I take the beginning, end, middle. So if I substitute it in there, and this is very easy, so but I show you the first one, maybe the next one also, then it's going to be negative 11. 0 easy, negative 5. And 3, 2 times 3, that will be 6, minus 5, and that will just be 1. So from there on, it was easy. So now, on the same grid, draw the line. I'm not finished. They want me to draw that line. So negative 3 and negative 11. I have to make it bigger again that you can see. I'm not going to get it correct with that bigger. Okay, so let's just see. Negative 3 and 11. Okay, there's 1, 2, and there is going to be 3. I just want to get that, and it's 1 down. Okay, I just want to see if this is correct here. Because it's 1, 2, 3, 4, 5, and there is the negative 11. And then it was the next one, 0 and negative 5, 0 and negative 5, and the next one, 3 and 1, 3 and 1. And then I just take my ruler, I think this is better. Okay. Again, I didn't write down my equations, and I prefer that you do that. And what was the red one? Okay, let's just see. The red one was y is equal to 1 minus 1 over x squared. Okay, and now we can go on. Then they ask you, okay, on the same grid, use your graph in to find the solution of the equation this in D. Okay, so if I find the solution of this, so it's where the two graphs are equal. So it's where 1 minus 1 over x squared is equal to 2x minus 5. So it's where they intersect. Now where do they? Oh, they intersect at quite a lot of places. If it's like this, they just want x values. So let's just start. X equals, it cuts, cuts, cuts. X equals, x equals. Okay. So if I look at the first one, okay, I'm going to just see, okay, now the first one, it cuts there, and I'm just going to see, okay, let's start from the negative side. What color can I use now? I have now all my colors. I'm going to use blue. So where it cuts there, I just go up, 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 and I read down there. And it's 0.1234. So it looks like in this case, negative 0.4. Negative 0, oh, the pen again, 0.4. And if I take this one, and it's going to be cut, 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 cut. And then this one is 0.4. But it depends on, another person can have 0.5. It depends on your graph. But mine is, in this case, 0. But I think in my teacher's guide it's 0.5. But I struggled a little bit with accuracy with this technology. And then the next one, okay, and that will be 2.9. Okay, and that's your solutions to that equation by reading it from the graph. And then rearrange this in the form, it's just nice algebra. They just want to do me nice algebra, and I love algebra. So in this case, it's just number. It's going to be number E. Is it the second one? Yes. So this was the first one. And this is the second one. And basically, I'm just going to rewrite that again. So I'm going to know what I usually do. What is the LCM? So let me do it like people like it more. So the LCM, this is the LCM, is x squared. So if you put it, make everything fractions, it's an equation. So you multiply your, oh, let me put it here. It's almost like I need space then. So x squared over 1, x squared, x squared. What I usually do is I make the denominators the same, and if it's an equation, I cancel it out. But I see people prefer this method, so let me do it on this method. So it's going to be then x squared, okay, but now in this case, it cancels out, so minus 1 is equal to 2x multiply that x squared minus 5x squared. So it's going to be x squared minus 1 equals 2x to the power of 3 minus 5x squared. Okay, just take everything to one side. Okay, Leave the highest, take it to the highest one, because it's positive there. I prefer it on this side. Just going to move it up a little bit. So it's going to be 2x3 minus 6x squared minus 1. And they don't expect you to solve this, okay, algebraically. In the next level of mathematics, in grade 12, we will solve cubic equations. But for now, they just want it in this form. And that was the final answer.